Hey kiddos, I'm sorry I missed you today, but things happen. Kids get sick, family needs to be taken care of. Anyway, I will see you guys Thursday, so don't worry about anything. All right? We have some wonderful substitutes today to take care of you, okay? However, I created this video to explain the lesson. This video is also located on YouTube in case you need to hear it a few more times. All right, so feel free to check it out. I do have a YouTube channel, but I'll share about that later. All right, so today we're going to start a new unit and we're going to talk about quadrilaterals. In this first image on slide 1, you have various shapes and you need to figure out which one doesn't belong. Well, I'm sorry, I'm going to miss the conversation about this, but hopefully you guys will notice various commonalities and differences, okay? Remember, which one doesn't belong mean there are lots of great answers to share, okay? On slide 2, you can see that I had some unsorted shapes. And at first I sorted them into 2 groups, but then I kept thinking and thinking even more. And then I realized maybe it's best if I sort them into 3 groups. So take a good look at these groups, okay? As you are thinking about them, come to slide 3, continue thinking, and this is the part where the substitute may pause this video so you guys can share some ideas either in the Google Meet chats or by raising your wonderful Google hands, okay? All right, I don't know how long it took, but hopefully after a couple of minutes, you guys figured out some commonalities among these groups. So on the left-hand side, we have some special shapes called trapezoids. In the middle, I'm sure you noticed we have square, rectangle, rhombus, parallelogram. And over here on the right-hand side, we have some oddballs. So let's see, is there any way we can name these groups? Well, I think the first group is somewhat easy. Trapezoids. The middle will be called the parallelogram family. Yes, it's a big family. It will include square, rectangle, rhombus, and parallelogram. Okay? I meant quadrilateral family. Sorry, long day. Quadrilaterals. Oh, where am I typing? There we go. Quadrilaterals. Okay? And last but not least, the oddballs. How can we call the oddballs? Those are going to be called polygons, okay? So then you might be wondering, what are polygons? Polygons are closed figures, two-dimensional, right? Like all the other guys here. Closed figures that are built out of straight lines, okay? Polygons. Let's go to the next slide. I put this video here because I would like you guys to pause mine and listen to the first 5.5 minutes of this video, which explains the relationship between the quadrilateral family members. Okay, so please pay attention and feel free to take notes in your math notebook. I hope you found the video useful. And I hope you understand the basics now, which is, how do we classify our quadrilaterals? The overall family is called quads. And the quads have 2 main groups. Trapezoids by themselves, because they have only 1 pair of parallel sides. And everybody else in the quad family is under parallelogram, and they all have 2 pairs of parallel sides, okay? Now there's something important here that I want you to pay attention to, okay? And I'm gonna draw this arrow here next to the parallelogram family. This is an important arrow, actually. It represents relationships. Listen to the following. Square, based on its characteristics, could be a rhombus. Square could also be a rectangle, and square could also be called a parallelogram, and most importantly, square could also be called a quadrilateral. I call this arrow bottom-up rule, okay? Now think about rhombus. Can rhombus be a square? No, the arrow points upward, so we cannot go back down, all right? They don't have enough similarities, so rhombus can never be a square. But rhombus can be a parallelogram, and a rhombus can be called a quadrilateral, okay? What about rectangle? Do rectangles have the same characteristics? Can it be a square? No, it can't. But rectangle can be a parallelogram, and rectangle can be a quadrilateral. If you're not the linear thinker, then I have a Venn diagram for you right here. And you see we have two main groups, right? Among the quads, we have the big parallelogram family, and then we have the trapezoids by themselves, all right? The Venn diagram shows that square is in this overlapping part between rectangle and rhombus, because square has characteristics that could make it a rhombus and a rectangle as well. Okay, so if you're not a linear thinker, this might be the image that helps you figure out the classification, okay? Again, take a look at these bubbles inside the parallelogram. That means that the square is a parallelogram, the rectangle is, and the rhombus is also a parallelogram, okay? Don't forget, these are also located in your notes in Schoology as always. Now come to slide 6. Yes, I know, lots of words, but please don't be scared. It's pretty easy to understand the different properties of each individual quadrilateral. There are a few things we are going to be thinking about and looking at when we are analyzing these characteristics or properties. Number one is the sides of the shape, okay? So you see these tick marks? I'm going to zoom in. One tick mark on opposite sides means those opposite sides are congruent. See, you already know this. Two tick marks on these opposite sides mean that those are congruent as well. So look, you already know that opposite sides in a parallelogram are congruent. Now, what are these little arrows on these opposite sides? Yeah, these should be double arrows, okay? They represent or show that those opposite sides are parallel, okay? So take a look at this. These opposite sides here have the one arrow, which means those are parallel as well. So look at this. We already know everything about the sides of the parallelogram just by looking at the markings on the shape. Let's continue from sides to angles. You've seen these angle arcs. What does it mean that I have one angle arc on the opposite angles? That they are congruent. What does it mean that I have two angle arcs on these opposite angles? That they are congruent. Nothing new here. Now here comes a new thing. Okay, and I'm going to color code it for you. Diagonals. Okay, diagonals are created when you connect the vertices, aka corners, okay? And these diagonals are bisecting, cutting each other in half into congruent pieces, okay? And they also divide the figure into congruent triangles, okay? Last information that you need to think about besides sides, angles, and diagonals of these shapes is line of symmetry. I'm going to use another color for that. Line of symmetry you can find everywhere around you, especially nature. Just think about the butterfly wings. Think about your face when you look in the mirror, right? Line of symmetry, when I draw a straight line through the middle, I'm trying to put it in the middle. Please bear with me. And I try to fold this shape. These two sides that are created by the line of symmetry will be now identical. Are they identical here? No, they are not. They're completely different. They do not fold back together on top of each other, which means poor parallelogram has no line of symmetry. However, take a look at the other shapes, and I'm going to try to zoom out so you can see that they will have various numbers of lines of symmetry. I think this is the info that you guys actually covered last year. The other groups were telling me that they were aware of line of symmetry, so I'm hoping that it's something that's not new for you guys either. Okay, let's go to slide 7, and this is the part where you're going to start playing and using the properties of quadrilaterals to identify what figure are we finding here based on the clues. Okay, so feel free to look back at slide 5 and slide 6 as you are trying to go through the slides here. Slide 8 says, clue number 1, this shape has exactly 4 angles. I'm sorry, we're talking about quadrilaterals. Everybody has 4 angles. So you are correct. You need to click yes to all of these options. Let's see if we get other clues that might help you narrow it down. All right, clue number 2 says I have 2 sets of parallel sides. So quadrilaterals like parallelogram, rectangle, rhombus, and square have parallel sides. But hold on, not all quadrilaterals have 2 pairs of parallel sides, because trapezoid and isosceles trapezoid are also quads, but they have only 1 pair of parallel sides. So make sure that you choose only parallelogram, rectangle, rhombus, and square. Let's go to slide 10. Let's see if this clue helps us narrow it even further down. My diagonals are congruent, aka my diagonals are exactly the same length. Well, feel free to look back at slide 6. Think about these diagonals. Where does it say diagonals are congruent? Oh, only rectangle and square have congruent diagonals. Let's go to slide 11. Last clue. I have 4 lines of symmetry. Feel free to go back to slide 6 to check which one of these had 4 lines of symmetry. It was only square. Or was it? Come to slide 12 and here's the big reveal. Yes, you guys narrowed it down based on these clues that the figure that they tried to think about here was square. Let's continue. Slide 13 starts with a new clue for a new figure. I have at least 1 line of symmetry. At least, remember, inequalities means at least 1 or more. So, remember, not all quads have lines of symmetry, which includes trapezoids. So, don't click on quads. However, what about parallelogram? Oh, we just talked about that. That doesn't have line of symmetry. So rectangle has 2, so that goes with at least 1. Rhombus is also good to go. Square with the 4 lines of symmetry. And there's a special guy here. Isosceles trapezoid. Don't believe me? Go back to slide 6. This is the isosceles trapezoid, okay? That means it has opposite sides congruent, which when I draw in the line of symmetry, will create identical sides, images, right? So the isosceles trapezoid has one line of symmetry. All right, back to slide 13. So I did click on 4 things here. Let's continue narrowing it down. I have no right angles. Ooh, so then rectangle is out. We can still keep rhombus, square is out, and we can still keep isosceles trapezoid. Slide 15. My opposite angles are not congruent. Between a rhombus and isosceles trapezoid, who has opposite angles not congruent? Bingo, bingo, bingo. It is isosceles trapezoid. Let's go to slide 16. Big reveal. Yep, nice job. Last group of clues. My diagonals bisect each other. Okay, so that will be parallelogram. We already talked about that. Rectangle, rhombus, and square. Slide 18. My diagonals bisect at right angles. Well, let's go to slide 6 to check. Diagonals bisect at right angles. Ooh, I see that on the rhombus. Where else do we see that? Ooh, I see that on the square. So let's go back to slide 18 and we can choose rhombus and square. Let's keep going. Clue number 3, last. I have no right angles. Oh, then square is out. Square has right angles, which means who is left? Rhombus. Well, I hope you found today's lesson fun. Now, before you run away, don't run away, don't run away. Let's see what else do you need to do here, okay? A couple of things. One, minor number 1 for similar figures is open, but before you do that, I highly recommend you complete the formative that is assigned in Schoology, okay, just to refresh your memory and double check yourself, okay? So formative first, then you can do the minor number 1. Please complete review number 3 and number 4, and I'm going to also post the answer key for review number 2 since I wasn't here today and we couldn't do it together. Okay, so check out Schoology for the reviews. You have a little Google slide, fun, interactive practice for quadrilaterals, so don't forget to complete that for next class, and your weekly 5 Dreambox lessons, okay? Please work on only assigned lessons and you need only 5. No more, only 5, okay? So when in doubt about the to-do list, just look under upcoming in Schoology. I have everything assigned for you, okay? And I hope you will have a fantastic rest of your day and I see you Thursday. Bye guys.